Radhe Radhe everyone. So I hope I'm audible. Okay. So in this video, we're going to discuss the Leetcode contest 474. This thing, okay, has ended. It was taking time to load. I haven't performed that good in this contest. Okay, so yeah, most of the questions I haven't done, but I got the gist of it, so I'll be explaining that. You don't need to worry about that. So let's start with the first question. Question 1 is find missing element. You're given an integer array nums consisting of unique integers. Originally, nums contains every integer with a certain range. However, some integers might have gone missing from the array. The smallest and largest elements are there in the array. Okay. You have to return a sorted list of all the missing integers in the range. If no integers are missing, return the integers. So let's go through it. So 1425, if you sort it out, okay, you sort out 1425. On sorting 1425, it becomes 1, 2, 4, 5. So 1 and 5 is there, but some numbers are missing in between 1 and 5 in the array. Okay. So over here it is clear that it is 3. Okay. So we have to return a list of 3. Okay. Similarly for this one, 7, 8, 6, 9. So if we sorted it becomes 6, 7, 8, 9, and none of them are missing. So we have to go with it. For this 5, 1. So 1 to 5, all the numbers between 1 and 5 are missing. Okay, so that is 2, 3, 4. Okay. You can do it in a more optimized pattern also. I have done it in the longer way. I mean, in a way that takes up more complexity. But you know what? Like at the end, you should remember that if it is allowing you to do it during contest specifically, you can try to go for the non-optimized ways also. But whenever you're practicing, try for the optimized ways. Okay. It is kind of simple. You just need a it will be big O of R. Okay, that is the largest number in the number. That is the solution that you would come up with in an optimized manner. But since I am using it, so I have gone for big O R into N, where N is the size of the number, so, size of the array. So what I'm doing is I'm taking L, the first element, R, the last element. Okay, and I'm excluding them from the range, +1 and -1. So it basically means that all the numbers from L to R should be there in the array, excluding the first and the last element after sorting. Okay. Now after sorting, I just check for all the elements and check if it is there in the array or not. If it is not there in the array, then I can add it to the answer. And similarly, it will be sorted for me also. Okay. So I hope this question is quite easy for you guys to understand. It was quite easy. I think I'm audible, right? Yes, people are watching. So if you guys are watching it and you guys are unable to write anything in the live chat, so what you guys can do is you guys can subscribe my channel, okay? Because I have put on a subscribe only layer for chats. Okay, so you guys can subscribe my channel and then try commenting. So that's it. We can continue with the video. So I hope this is clear with you guys. Just okay, I'll just open a poll. I'll just tell me if it is clear or not. I hope it is clear. Okay, I hope it is clear. This was the easy one. I think many of them have uh, done this. Yeah, there are a lot of people who have done this. So it's a good one. Let's go to the next question. Okay. After the black check, it can be 5500. It doesn't matter. These night, this thing, it's just a matter of fact. Okay. So let's go to the second question. Maximum product of three elements after one replacement. This is a very okay. This is a easier part of the medium problem. Okay. This is a quite easier medium problem. Given an integer array nums, you must replace exactly one element of the array with any integer from minus 10 to the 5 to 10 to the 5. Okay. After performing the single replacement, determine the maximum possible product of any three elements at distinct indices from the modified array. So, you have to find the maximum product of any three elements in the array after replacing any one element with minus 10 to the power 5 to 10 to the power 5, any number in between them. You have to return the integer denoting the maximum product. So you have some numbers, so minus 570. So what I will do is, I will remove the 0 and make it minus 10 to the 5. And that is, these things, if I multiply, it becomes 350. So this is the maximum that I can get. For this case, I think I would be going for 1500. I will be removing minus 2 and making it 1500. Okay. So that is a good one. Yeah. So here, okay, there are two ways to achieve it. You can remove the minus 2, also the minus 1. Okay. So minus 4, minus 3 I'm keeping, and any one of them I make 10 to the 5 and I get the max. Okay. In this case 0, 10, 0. So I can either remove this or remove this or remove this. So if I remove this, it is 0. If I remove this, it is also 0. If I remove this, then also 0. So no matter whatever you do, its answer is 0. So what is the best way to do this? The best way to do this is in a greedy manner. That is, like if there are three possible numbers that you can take, so how many permutations are there? Right? How many permutations are there? In a greedy manner. So you have to take any two of them. Because see, among the three, one is fixed. Obviously, you will make it 10 to the power 5 only, okay? Because it was given that all the numbers in nums are also in this range. Okay. So if it is 10 to the 5, you can replace it with 10 to the 5. Not an issue. Correct. So not an issue. So you have to take two numbers, and the other number will be either minus 10 to the 5 or 10 to the 5, because you have to maximize it. When will it be minus 10 to the 5? When the product is negative. So negative, negative, positive. If the product is positive, then 10 to the 5. Right? Now how to get the maximum and the minimum product? Because see, minimum means the least negative number that you would have got. Okay, the least negative. Let's say minus 10 to the power something. So that is the least negative that you can get. So obviously it is a matter of minima and maxima. Okay, so if you guys know about the graph and those things, so x squared, let's say x into y. Okay. I have to find the maximum value of x into y. So x into y. So you know how to differentiate it. So if you differentiate it, you know d dx, right? So the graph will be looking like this. Let's say there is a maximum minima like this. So everything is dependent upon this minima, the second largest maxima, the largest maximum, and the second largest minimum, second smallest minimum. So these 4 points are the ones. These 4 points are the ones for which we have to check. We have to take any two elements from these 4 points. That is the largest, second largest element, smallest, and second smallest element. Okay. So what you can do is you can sort it out first of all. You can sort the whole array. Okay. And then you know that you need any two elements from 4. So that is 4c2. What is 4c2? It is 4 into 3 by 2. Okay, it is 6. I don't know why I have done so much of things. Okay. Actually, this was not needed, I think. Yeah, this was not needed. My mistake. My mistake. Oh, no, 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 no. This was needed. Yeah, this was not needed because I am taking, jump to C please. See, I am taking 0 and n minus 1 wise. Okay, so I am considering all the permutation combinations 0 to 1, 0 to n minus 2. N minus 2 is the second largest element, n minus 1 is the largest element, 0 is the smallest element, and 1 is the second smallest element. So try to multiply two of them in any pattern you want. Okay, I have multiplied them, and then I am sorting the array. Okay, and then I am finding whichever is maximum. Okay, the least negative number and the largest positive number. So this is the largest positive number and this is the least negative number. So the negative number you have to multiply with minus 10 to the 5 and the positive number you have to multiply with plus 10 to the 5. So you multiply them with them, and whatever you get, the answer is, then be assured that that will be your answer. Okay. So I hope that is clear. I think that is clear. People are asking to jump to C directly. C is a very good question. Okay. C is a very good question. I have the solution handy, a solution which aligns best with what I was trying to do. So I'll tell you the first. I'll discuss the question. So the third question is minimum time to complete all deliveries. You're given two integer arrays of size 2. These D1, D2, R is R1, R2. Two delivery drones are tasked with completing a specific number of deliveries. Drone I must complete DI deliveries, and drone 1 must complete drone D1 deliveries, and drone 2 must complete D2 deliveries. They can't deliver on R1 and R2's multiples. Drone 1 can't deliver on R1 multiples because it will be recharging itself. That is, both drones require recharging at specific intervals during which they cannot make deliveries. Drone I must recharge every RI hours, that is, at hours that are multiple of RI. Okay. Each delivery takes exactly 1 hour, and only one drone can make a delivery at any given hour. So for one specific hour, you have only one drone. Okay, this is also a point to note. To be noted. Okay. So um, I hope you are pretty much good with what the question is telling us. Return an integer denoting the minimum total time that requires to complete all deliveries. So now think of it like you have one drone. Ignore my drawing. Okay, you have got one drone, and this is your second drone. Okay, this is a very mathematical question. This is a very mathematical question. This drone will be delivering exactly D1 deliveries. This will be delivering exactly D2 deliveries. On every multiple of R1, we have to charge this. On every multiple of R2, we have to charge this. In second column, I just converted every number to positive number and then sorted the array and did nth element n minus 1. Yeah, that is a better one. This is a better solution. This is a better solution. Correct. No edge cases. No edge cases is the best solution. Good one for that. So D1, R1, D2. So for LCM of R1 from R2, okay, the LCM, that is a time when both the drones will be charged. So both of them will be idle. So no deliveries will be done on that time. Okay. This one is very clear. Anything else that you need to know? Yeah, that's more than enough. Now we have to find the calculation that is possible. Okay, let's deep dive into it. Let's brainstorm into it. The brainstorm will be looking like that. First of all, I know that D1 deliveries need to be done by drone. So what I can do is I can try giving the slots to the drone 1 as much as possible. So let's say I've got 10 slots, that is for time 1 to 10. Okay. Drone 1 can deliver on 1. So I will give to drone 1. Drone 1 can deliver on 2. I will give to drone 1 only. Drone 1 can't deliver on 3. That is R1 is equal to 3. Let's say. So drone 1 can't deliver. So I will try giving it to drone 2. Okay, I will try giving it to drone 2. But what if R2 is also 3? You never know. So I can't give that slot to anyone. Okay. But that is an exceptional case. Now I will give it to drone 2. Then again R1 comes. I will give it to R1. I will give it to R1. And again he is free. I will give it to drone 2. So it is a kind of greedy algorithm only, right? In the beginning. But this question, sorry, not this one. This question, it gives that D1 is lesser than or equal to 10 to the power 9. So even if you know that it is a greedy algorithm question, it is not possible for you to solve it using greedy. Okay. So you have to find out something arithmetic. Now I just told you one arithmetical expression, that is the LCM part. Okay. Now that you know the LCM part, you know that during this LCM parts there will be nothing. So one thing, is it clear that we will be needing a binary search on this? Because let's say 1 to 10 to the power 9. Okay. This is what the whole array will look like. Or rather 10 to the power more than 9. It would be, let's say, 10 to the power, what was the range? Just a minute, I'll just tell you what the solution, what the maximum can be. It is add all of them. Okay. That's the best thing to do. 10 to the 9, 10 to the 9, 2 to 10 to the 9, 3 to 10 to the 9. So let's say 3 to 10 to the 9. 10 to the 15 is too much. Okay. You don't need that much. But yeah, okay, let's say 10 to the 15. 10 to the 15. Best. That's fair. So if I binary search on this, so I will reach to some position. And in that position, what I will try to do is, I try to give some positions to 1 and some positions to 2. Okay. And check that the number of 1s is greater than or equal to D1 or not. And the number of 2s is greater than or equal to D2 or not. So if it is possible, then that is a possible answer, and we can reduce, we can make R is equal to mid minus 1, right? That is what we do in binary search, right? If it is not the condition, then L is equal to mid plus 1, correct? Now the point is, how would we know the condition? Okay, now look at this solution. Okay, this guy is provided. D1 is equal to D of 0, D2 is equal to D of 1. R1 is equal to R of 0, R2 is equal to R of 1. Okay, you know what D1, D2 and R1 is. Left is equal to 0, right is equal to, he is going for the maximum value. You are going for 10 to the 5, is 10 to the 15, he is going for the maximum value that you can have. Because yeah, we are good to go with it. While left is less than right, mid you know what it is. Now he is going for condition to work. Okay, we don't know the logic, but this is the whole logic that is needed. And he is making right is equal to mid and left is equal to mid plus 1. This is done because he is more aligned to return right. He is not using an answer. Okay, if he would have been using an answer, then it would be less than equal to answer is equal to mid, right is equal to mid minus 1. That one that I was showing. Okay. Like this, like this. Uh-huh. No, 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 no. Actually, the computer lag, my screen lags when I. So somewhat like this. It would be looking somewhat like this. L less than equal to R. If this condition satisfies, R equal to mid minus 1, answer is equal to mid. So you guys know this. Okay, else, you guys know this. This won't be a much of an issue. Now, what is the condition to work? We would be needing GCD. Why? Because you remember I told you that we would be needing the LCM part, right? Now, you know the formula of LCM. LCM is nothing but the two numbers divided by HCM or GCD, whatever you like calling it. Okay? So you know the HCF. Yeah, correct. Now, see, what is the condition to work? This is a very, very interesting arithmetic thing. So first of all, he is taking the GCD and the LCM. Okay. See, I just told you that A into B by GCD, but he is doing like A by GCD into B. Why so? So that the overflow doesn't occur. He is doing this because the overflow doesn't occur, but we are good to go with A into B by GCD. You don't need to worry about that. Now see, exclusive for 1. What does that mean? That is, the recharge points which are applicable for drone 1 only. So that means the recharge points for drone 1 excluding the LCM, because LCM means those recharge points are common for both the drones. So we won't be taking that. Okay. How to find that? It is nothing but T by R2. Why T? T is the uh, time that we are currently thinking of as the answer. Okay. So let's say I would take 6 hours. So T is 6. I would take 7 hours. T is 7. Okay. That by R2. Why R2? Because let's say you're having seven slots. Okay. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. And your R1 is 3, which means this will be occupied, this will be occupied. So how many are you are using? 1, 2, 3, 4, 5, right? You're using 5. Now see, and you're not using 2. Okay. Now see what he's trying to do. T by R2 minus T by common multiple. Let's not focus on the T by common multiple, okay? Let's focus on T by R2 first. So what is T by R2? 7 by 3. What is it? 2. That is the number of blank spots where the drone is not going to work. Correct? Now, this is where the drone 2 is not going to work. Rather, I think he has altered the numbers, okay? And this is where the drone 1 is not going to work. He has altered the numbers. Okay. Minus T by common multiple. Okay. Minus T by common multiple. Why common multiple? Common multiple is the LCM, where both the drones are not going to work. Okay. So, it means that over here, what am I going to get? The positions where only drone 2 is not going to work. And this is for the positions where drone 1 is only not going to work. Okay. Now what is the available? Available is T is there, minus T by R2 minus T by R1 plus T by common multiple. That is the paths that are this. For this you need to understand sets. You know what is a set? Let's say there is a whole thing like this and this is there. Okay. So how would you find out this area? This is nothing but this, right? Union, whatever the universal set, or as I think it is the universal set minus A plus B. Now A plus B, whenever you are using A plus B, this specific area is considered twice. So minus A intersection B. Correct? This is the formula. Now let's have a look at this. What is the formula he is using? T minus T by R2 T by R1 plus T. Because this minus becomes minus, this plus becomes minus, and this becomes plus. Okay, universal minus A minus B plus A intersection B. I hope there is no doubt on this. Any doubt on this? Because this is the last 3 lines that is needed. That is remaining. Okay. Any doubt on this till now? You guys can tell me in the comments. I mean, in the live chat. I got it. Okay. Great, man. Great. So now see what is need one. That is the one needed for one. Okay. That is D1 minus exclusive for 1, and this is D2 minus exclusive for 2. What does that mean? So you remember what we were doing? For exclusive for 1, we were setting it for 2. For exclusive for 2, we were setting it as 1. Which means that for, if I start today, how long before I can solve the third question in Leetcode? Depends. Like, I think the third question in Leetcode, there is nothing as like the third question in Leetcode. It is like different contests have different levels for third question. So it depends. But at least you should be able to understand the third question. I mean, at least you should be able to try to get into the third question. Okay, like just by seeing the question, you should have a knowledge that okay, this is going to be a binary search. So these type of things that should come. I get it. I get it. 3 by 4. I get it. The fourth or the third question. I get it. But these things are like it comes. At least if you're able to understand that this is the algorithm that I have to use, the binary search I have to use. So that is also more than enough because in today's contest I haven't done all the three of them. But I understood that this is there, but I couldn't come up with the formulas, okay? Because these things it is very complex for me to write. The formulas basically. Formulae. CP is whole different ball game. I just want to be good at Leetcode. I get it, I get it. We want to be good at Leetcode, just practice Leetcode, follow some sheets, वगैरह, more than enough. So need one is D1 minus exclusive for 1. Okay. And need 2 is D2 minus exclusive for 2. I'm not able to come up with complete task. Complete task. Acha, condition to work. I'm not able to come up with the complete task. I think yeah, you're talking about quantity is different. I have seen only CP guys clear it. Okay, let me just explain this first, then I'll explain. So need one is math.max 0, D1 minus exclusive for 1. That means these are the number of deliveries that he has to do. And exclusive for 1. Okay. So that is the uh, the time when D2 was charging. Only D2 was charging. Okay. So D1 can use them. Okay. D1 can use them. So since D2 was charging, so D1 can use them. So D1 minus this and D2 minus the opposite thing. If return is greater than equal to need 1 plus need 2, then you can return. What is available? You know, available is nothing but I just explained you the set thing, okay? That is the available part. So available, if it is greater than equal to need 1 plus need 2, that means we have already satisfied D1 and D2, okay? If it is possible, then well and good enough, you can go for it. If it's not possible, then R is equal to, sorry, L is equal to mid plus 1. Higher the standards, okay? Any doubt on this? Guys, any doubt on this? Contest question is different. I have seen only CP guys play. See, what happens in contest questions? Huh? In contest questions, whatever the problems are there, it is somewhat similar to questions that you have done also. Okay. But during the contest, how does it ensure that only one rune is assigned at one time slot? It is ensured by using this. No, it is not. See, I am not ensuring it. Okay, I am not ensuring. See, how would I make you understand this? Let's consider what is the need one. Okay, need one. Need one is D1 minus exclusive for 1. That is D1, the number of deliveries that the first rule needs to do, minus the slots that are exclusive for 2. Okay. Because the slots that are exclusive for 2, I won't be allowing this. Sorry, I messed it up. I will be allowing this to do that. Okay. You're getting it? D1 minus exclusive for 1. I'll come later. I think this question will take time. I also think that like if you haven't thought of this question during the contest, then it will take time. If you had spent some time on this question, then it's easier to understand. I think till over here it was very much easy to understand. Okay? This is the main part where the whole thing gets tricky. Okay. The tricky part is that D1 minus exclusive for 1 and D2 minus exclusive for 2. I think I'll need the graph to make you understand this. See, let's say 1 2 3 4 5 6 7 8 9 10. Okay. Let's say one of them is 2, the other is 6, or rather 4. Chalo, 4 is a better answer. This is the values of R. Okay. D ka values I won't explain now, I'll come later. Which means that this slot is booked. I mean, this slot is for recharge, this slot is for recharge, this slot is. My mistake, my mistake. I was about to highlight 2. This is recharge, this is for recharge, this is for recharge, this is for recharge, this is for recharge, and this is for recharge. Correct? And the one for the second row, this is for recharge. Sorry, not this one. This is for recharge, and nothing else is for recharge. This is clear. Now let's understand what the numbers, this numbers will be. What is exclusive for 1? It is t by r2 minus t by common multiple. T is 10 over here. Okay? T by r2, that is 5, plus t by 4, that is 10 by 4, that is 2. So 5 minus 2, correct? That is 3. That is these ones, the ones which are only for 1. Okay, that is exclusive for 2. Okay, that is exclusive for 2. Okay, this is exclusive for 2. What is exclusive for 1? It will be nothing actually. Okay, it will be nothing actually. Because t by r2 minus t by common multiple, and r2 and common multiple both are same. The LCM of this 2 and 4 is 4, and this is also. So E1 is 0. Correct? E1 is 0. But if at any position there was something like this, and this was not there, then it would have been contributed to E1. Okay. So E1 is 0 and E2 is 1, 2, 3. 3, right? Clear? Now understand this. Available. It is T minus T1, T by R2 minus T by R1 plus T by common multiple. Okay. 10 minus T by R1, that is 5, minus 10 by 4, that is 2, plus 2. So these two are getting cancelled out, remaining is 5. If you look at what is the available parts that are remaining, it is 5. 1, 2, 3, 4, 5. Right? Till now it is clear. I hope it is clear. So now what we are going to do is, what is need 1? I don't know what is need 1. Got, you got it? Do I need to explain it or not? D1 minus exclusive for 1. Okay, I'll explain it. Now see, D1 was, let's say, now the value of D1 is going to come. D1, let's say it is D1 का कुछ अच्छा वैल्यू निकालना पड़ेगा, D का कुछ अच्छा. So that the like I would be able to explain it to you, so I have to think of some good numbers. D, let's say good one. D is 5 and this is 3. 3 6 ना 5 और 3 देखो भाई. अब मजा आएगा, ठीक है समझने में. Now D1 is 5, right? D1 minus exclusive for 1. 5 minus 0. Why 0? Because 0 means the slots which are available for E1. So 5 minus 0 is 5. Correct? So what is need 1? It is 5. Correct? Need 1 is 5. What is need 2? It is 3 minus um, 3 minus 3 minus 3 होता है क्या? हाँ 3 minus 3, that is 0. Correct? Need 2 is 0. Add them, 5 plus 0 is 5. What is available? Available was also 5. 5 greater than equal to 5? Yes. We get the answer. Why so? See, this need 5, this 5. What am I assigning to them? The slots which are needed by none. This. Correct? This need to become 0. Why? Because these are these slots 1, 2, 3. These 3. Okay. Let's say this 3 would have been 2. Okay, let's say this 3 would have been 2. Then this would have been um, क्या बनता है ये? क्या बनता है ये? What this would have been? And 2 is 2 minus that. 2 minus क्या होगा? 2 minus exclusive for 2. That is 2 minus 3. Right? N2 would have been minus 1. But क्या minus 1 possible है? नहीं. So I will make it 0. Okay. So this is the reason we are using math.max. Minus 1 मतलब कि भाई मेरे पास 3 स्लॉट खाली था. ठीक है? इसको फिल करने के बाद मेरे पास 3 स्लॉट खाली था. बट उसमें से मैंने बस 2 ही स्लॉट निकाला है. So मेरे पास अभी भी एक स्लॉट खाली है. But I won't be considering that slot. ठीक है? Because I can't put anything in that slot. ठीक है? I can't put this one in that slot. समझ लो? This 5 में से I can't put this 5 in this slot जो खाली है मेरे लिए. इसको 2 में डालने के बाद. Okay. So this is the whole logic of it. If it is still getting a little bit hard for you to understand, I'll suggest you कि रेस्ट ले लो, फिर वापस आना वीडियो में, फिर वापस देखना है. ठीक है, क्वेश्चन को देखना वापस और फिर एक्सप्लेनेशन देखना. क्रिस्टल क्लियर? बस, वेरी गुड. चलो, नाउ दिस question I have seen it, I have read the question, but I haven't attempted it. This is the fourth question. Lexicographically smallest palindromic permutation greater than target. You're given two strings S and target. You have to return the lexicographically smallest string, that is both the palindromic permutation of S and a strictly greater than target. If no such permutation exists, return an empty string. String A is lexicographically strictly greater than B. Or you know what is the lexicographically thing. A permutation is a rearrangement. You know what is a permutation. You know what is a palindrome. So I won't be explaining all of it. So you have to find a permutation of S, which is a palindrome and greater than target. B double A B. Okay. B A B A. B B A A. So what is the largest palindrome that you can get? This is the largest palindrome. No. I'm not targeting it, please. I know they are paying a lot of huge amount of API, but I don't think I'm worthy of that. So BAAB, okay, BAAB is a, so BAAB is already lexicographically smaller than BAA, so there is nothing. ABC, ABB. ABC can never make a palindrome only, so it's a blank. Okay. So I hope this is clear. Question is clear. AAC, only one palindrome is there, one CA. Sorry, AC. No, it is out of interest, man. At this moment, it is out of interest. I don't know. Later part, I don't know what I'm doing. So this was given that it is 300. Okay. This was given that it is 300. So I think a recursive would have worked. I haven't seen the solution. So it tells us. So let's try to understand. It tells us that think of it like finding the next palindrome permutation, just greater than target. You're only building the left half. Correct. So whenever you find some questions like this, the palindrome which is greater than this, a palindrome which is, remember you're just building the left half. Okay, the right half is not what you're building. Okay, because whatever the left half is, the right half is just a mirror image of that. You don't need to do it. Carefully picking characters so that the result is palindrome. Okay, is the next possible one path. Number one, check if a palindrome is even possible. Okay, if it's not possible, return this. So you know how to check it. You can have a frequency array, and you can allow at most one element to have its frequency as odd. Okay, other elements will be that. So at most one element can have odd frequency. That becomes so. This is very clear. This part is clear. Okay, chalo. Let's go to the next one. Build only half of the palindrome. A palindrome is symmetric, so you need to. I just told you what this is. So half counts is, so okay. He's telling you that take the half count of it. Okay. Don't take the whole count of it. Take the half count of it. And if there is a if there is a middle element, then you can take that also, or you can remove that also. That also doesn't matter. Yeah, that also doesn't matter. You just take the half count of it. Okay, works perfectly good for you. So it becomes A is 1, B is 1. So the halves are AB, BA. Correct? AB, BA. So AB is 1 and BA is 1. Just consider the halves. Don't look at the remaining part, because that is by default the mirror image. Okay? Recursive building, the find function. This is the core logic. Okay, I don't know what it is. You try to fill the half string from left to right. At each position k, you decide which character to place. You only choose characters that still have remaining frequency in half count. Okay. You only choose characters that still have remaining frequency in half count. Why would you do that? You try to fill the half string from left to right. From left to right, okay. At each position k, you decide which character to place. You only choose characters that still have remaining frequency in half count. Remaining frequency in half count. I still don't get why this is getting done. Okay, but still, let's try to understand the whole thing, what he's trying to tell us. But there's a key concept. We need the smallest palindrome greater than the target, not just any palindrome. Good one. If we are already greater is equal to true, we can really use A to Z for the rest. Correct. Brilliant. So that means that if we have already reached the maximum, because we are traveling from left to right, right? So let's say we have the target. We can also divide the target into two parts. Okay. And the palindrome that we are going to make, that will also have two parts. So we can go on checking that make this normal, make this normal. So okay. See, you can only keep, let's say if this is B. Okay. In this part you can keep any alphabet from B to Z. Okay. If you're keeping B, so you have to be very strict with the remaining ones. But if you're putting anything from C to Z, let's say if you're putting C only, then you can put anything over here. And what will anything will be? This will be the smallest in increasing order. Okay, in increasing order you can put them. Because you have already got this, whatever you're putting over here, you have already got the largest. Okay, this is one trick that you can follow. I think this is the only trick that you have to follow. I think I messed it up. I should have coded this out. I messed it up. I should have coded this out. That is the only thing. Yeah, that's the only thing that. If we are still equal to the prefix, we must pick a character. Yeah, greater than equal to target of k. That is, if this is b, we have to create greater than equal to b. That is b to z. The exact thing that I just explained to you. This ensures we don't generate smaller or equal strings. Base case, check if found palindrome is valid. Okay. When the half is fully built, mirror it to create a full palindrome compared with target. If it's greater, return true, else backtrack and try the next possible. Okay. Why would you backtrack? Why would you need to backtrack? Let's say this was B, this was B. Okay. I was very much sure that okay, this can be B. And then I went on till over here, I made the whole thing, and then I realized that in this part, because this is not a palindrome, Target is not a palindrome. This is a palindrome. So in this part, I realized that okay, now it is not lexicographically smaller. So I have to again backtrack and replace any one of them. Okay, let's say this was a C. So I have to replace it with D and then check. Still not possible. Again go backtrack. Now let's say we have come to B. So replace it with C and check. Is it possible? It is possible. Okay, we are returning. If it is not possible after backtracking till over here, then we can do nothing but return an empty string. Okay. Any doubt on this question? On this, I can show you the code what he has done, but I got the basic logic about it. So first of all, let's go back to this one. He's taking the count. Only one can be odd, so he's counting the number of odds. If odd is greater than one, return. Okay. For int I is equal to 0, I less than 26. He's just making the count as half. Okay. So that he just needs the first half. N half is equal to n by 2. Half str dot resize. So he's just resizing the half str to more n half. Okay. So he has got what was half str value? Okay, he was putting something over there. Got it, got it, got it. This is going to be used for that thing. Got it. So n half is equal to n by 2. Half str dot resize n half. If find of 0 comma false, that is string reverse half, it's equal to half of string, half string, half str, and then he's reversing it and then he's adding them. Okay. If there's a mid character, then also you have to check. You know what the mid character is? It is the count where the odd was 1. Okay. Mid character is where the count was odd. Okay. So this is the find. This is the core logic. What he is trying to do. Int k boolean is greater. Okay. So initially boolean is false. It is not greater. Okay. So here's where's the function? Why can't I find the function? Yeah. So initially he's keeping it as false. And then what is k? K is the size. Okay. So if k is equal to n half, then string rev half is equal to half of str, and we reverse it and then we return it. Okay. If it is possible or not. This is for the find. And for the character, he is just doing the same thing. Okay. I hope I don't need to explain this. Okay, this is a little bit complex code, but if you know the logic, you can check out this solution later on, and you'll get it. This is a backtracking question. So let's come to the last part of today's contest, where we will be rating the problems. Okay. See, the first question, well and good enough, but it was easy. If you want to go for a little bit of better part of it, then also it is a little bit higher than easy, but on easy. Okay, on an easy scale. B was maximum product. Okay, that was also on an easier part of medium. C was on a harder part of medium, and D was also on a harder part of medium, not hard. Okay. So okay, guys, that's it. I think So we have come to the end of the stream. It was a great stream. We'll be meeting you guys on next Sunday if possible, because I can't assure that I will be live streaming or not. Okay, so if possible, I'll try to attempt the next contest also the next Sunday. This contest, I think my rating will go a little bit down. I mean, a lot down. Okay. So okay, that's it from my side. Thank you guys for joining. Chalo, bye.